Hey there, friends. My name's Matthew. I'm the C# artisan, and this is the first video in my new series on threads. And no, I'm not talking about threads like these magnificent threads. I'm talking about software threads, the programming concept. So your first reaction might be, really? Threads? I thought we were in the post-thread era. Do we really need to think about that? Well, I'm going to give you 3 reasons why you might want to think about threads. First, it's true that C# tasks and the async await pattern are really easy to use, and they hide away a lot of the complexity of using threads directly. But it's still nice to know what's going on under the hood. That makes you a better programmer if you understand what the framework is doing for you. Second, some of the concepts related to thread safety and sharing of data apply just the same whether you're explicitly creating threads or using tasks. And last, there probably still are some programming problems which are best modeled with an explicitly created long-running worker thread. So I think it's worth studying. I also think it's a lot of fun. So I hope you'll join me on this journey into exploring threads. And let's just begin with the fundamental question. What is a thread? To answer the question, what is a thread? I'm actually going to take one step back and ask, what is a process? What even is a computer program? So when we write code and we compile it, it turns into basically just a long list of instructions, a whole bunch of computer instructions. And when we run our software, the operating system creates a process, and then it just runs through the list of instructions. So here we have a diagram. Up top is my model of the CPU, and we've got one process kind of loaded up here. And because we only have one process on this computer, 100% of the CPU's time is dedicated to that process. And as it runs, as that process is active, the CPU can just churn through all of the instructions in that process, one after another. Now, of course, it would be very weird to have a computer with only a single process. Usually, there are multiple processes. So let's take the simple example of 2 processes. So how does that work? The reality is the CPU can only work on one at a time. So as these programs begin to run, the first thing is the CPU is allocated some time to the first process, and it runs through some of P1's instructions. Then it switches, and P2 gets some time. All of the instructions that were completed for process 1 are done, and now the CPU is working on process 2, and then it switches back. So in reality, there are dozens and dozens, maybe even 100 processes or more on your computer, and you probably have more than one CPU core, but basically this pattern explains what's happening. They're all getting slices of time, and the CPU is running through their instruction set. Now, if it was the case that a process only had one instruction set, that is, if there was no parallelization at the process level, you really wouldn't need the concept of threads. You could just say the process has its instruction list and that's it. But the reality is, while some processes maybe just have one instruction set, others get a little fancy and they want to work on 2 sets of instructions at the same time. So this is where threads come into play, because what is assigned to be run is then called the thread, which is the set of instructions. So in this diagram, process 1 has a main thread, T1, and a process always has a main thread. There's always at least one thread. And process 2 also has a main thread. And now process 3 is the fancy one. It's got its main thread, and it also has created a worker thread. So what happens when these processes run on the computer. Process 1 starts, T1 gets a set of instructions and it runs through them. And then it switches. T2 gets a slice of time. You can see T1's instructions are complete up to here, and then some of T2's instructions go. And then it switches again, and we get to T3. And then we get some time allocated to T4, which is process 3's worker thread. And then the whole process repeats. So again, if there were only ever one thread per process, you probably wouldn't need this concept of a thread. But because processes can create multiple threads or want multiple instruction sets, we call it a thread, and that's how the operating system allocates time. So in this definition, really, a thread really just represents a set of instructions. Now, under the hood, there's some complexity. There's data and other things, but really it's very simple to think of it as a set of instructions owned by a process that you want to get run. It's just a part of your program. So in the .NET world, we are not really dealing with operating system threads directly. We are dealing with what are called managed threads. So in C#, when you create a thread, it's a managed thread. And these threads are managed in what's called a thread pool. This works very similarly to like a connection pool for database connections. So let's say that process 1 has started. It gets its main thread, and its main thread gets assigned a thread from the pool. T1 is now running these instructions. And then let's say that what process 1 does is it decides to create some worker threads so that it can parallelize its work. We don't want to paralyze the work. We want to parallelize it. So the thread pool, the .NET framework, assigns thread pool threads to each of these workers. So now we've got 4 threads assigned, and they are all getting slices of time with the CPU and working through their instruction sets. Now, let's say that this 4th worker on thread 8 is done. It has run through all of its instructions and it's finished. So when it goes away, what happens? Well, quite simply, it goes away and thread 8 returns to the pool. Again, basic pooling, just like database connection pooling works. So the key concept here is that when you create a thread, you're not really creating something, you're pulling something out of a pool, and there is a limited resource, right? The pool is not infinite. And as long as you're using the thread, another process or thread can't use it. So it's important to grab the thread when you need it and use it, and then return it back to the pool when you're done. So there's my basic concept of threading. Now, there are many other interesting things we can delve into and maybe will further along, but for now, I think that's enough to get started. So there's your introduction to threading, and in the next video, we're actually just going to create some worker threads and watch them go. I'll see you in a sec. Hey there, C# friends. Are you enjoying these videos and finding them helpful? I hope so, and if you are, please go ahead and like the video on YouTube. If you haven't already, please subscribe to my channel and feel free to leave a comment. I would love to hear from you.